Kubernetes security isn't just one thing. It's about building a fortress, layer by layer. Today, that's exactly what we're going to do. We're going to cover count them, 8 critical layers of defense, from the network gates all the way down to the foundation, giving you real, actionable steps to make your clusters practically untouchable. So, picture this. It's 3 a.m. Your phone just absolutely explodes with alerts. Someone, right now, just got root access to your production Kubernetes cluster, all thanks to a single, misconfigured service account.
And poof, just like that, 47 million user records are gone. This isn't some made-up story. This is the nightmare scenario that literally keeps engineers like us up at night.
But what if that attack never even had a chance? What if you had a fortress so strong the attacker would have been stopped at every single turn? Well, that's what we're building today. In the next few minutes, I'm going to show you the 8 security layers that would have stopped this breach cold.
All right, here's our game plan. We're running what I call the engineer's gauntlet. First, we're securing the gates. Then, we're hardening the workload. After that, we shift left to verify the pipeline. And finally, we protect the foundation. Let's do this. First up, securing the gates. This is all about controlling who gets in and what they can talk to once they're inside. And we're going to do this with 2 incredibly powerful tools: role-based access control, or RBAC, and network policies.
Now here's where most teams mess up, big time. The threat? It's a classic 1-2 punch. First, everyone uses that default service account, which often has godlike powers. The fix is so simple: a dedicated, least privileged service account for every single workload. Second, the internal network is a wide-open free-for-all. Any pod can talk to any other pod. The solution? A default deny network policy that locks everything down from the start.
And this right here, this is the proof in the pudding. On the left, a beautiful, minimal RBAC role. It can only read pod info. And check out that last line: auto mount service account token is false. Pro tip: if your pod doesn't need to talk to the Kubernetes API, don't give it the keys to the car. On the right, you're looking at the simplest yet most powerful network policy there is. It selects every pod, and with no rules, it blocks all traffic. Period. That's zero trust in action. So here's your quick win, your mission for this layer. Go create just one dedicated service account for your main app. Then apply a single default deny policy in a test namespace. I promise you something's going to break, and you'll be absolutely amazed at what you learn about your app's secret traffic patterns.
Okay, the gates are secure. Let's move deeper inside to our second domain, hardening the workload. This is all about locking down the pod itself and, maybe more importantly, how it handles your most sensitive data.
The threats here are, well, fundamental. First, running containers as root. I mean, come on, if an attacker breaks out, they own the node. Second, Kubernetes secrets. Let's be real, they're just base 64 encoded plaintext. The great news is the solutions are now built right into Kubernetes, the restricted profile of pod security standards, and true at-rest encryption for your secrets using a key management service.
And this is what that looks like. These 4 lines of YAML, they are your new best friends. Run as non-root is pretty obvious, but allow privilege escalation false is absolutely crucial. It stops a process from getting more power than its parent.Ccomp profile blocks dangerous system calls, and drop all strips away every Linux capability you can think of. It forces you to justify adding back only what you absolutely need. This is defense in depth at the process level.
Okay, I'm going to pause here for a second because this is so important. Can we all just say it together? Base 64 is not encryption. It's just a way of representing binary data as text. Anyone who can read that secret can decode it instantly.
All right, time for your next quick win. Go to a test namespace and enable pod security standards in audit mode. It's safe, it won't break a thing, it'll just log any violations. Then I want you to run kubectl get secret and pipe that to base 64D. Go on, prove it to yourself. See your precious secrets in glorious, unadulterated plain text.
Okay, we've secured the cluster itself. But you know what's even better? Killing threats before they ever get a chance to run. So now we shift left to our third domain, verifying the pipeline. The threat here is sneaky. It's all the vulnerabilities hiding in your base images and untrusted code sneaking into your final product. The solution is a 2-pronged attack. First, automated vulnerability scanning with awesome open-source tools like Trivy.
Second, you gotta cryptographically sign every single image with something like SigStore to guarantee its origin and prove it hasn't been tampered with.
And this is what a truly secure CI/CD pipeline looks like in the real world. Step 1. Trivy image scans for high-end critical vaults, and it fails the build if it finds any. Step 2. Cosign sign cryptographically signs the image. Step 3, and this is so important, cosign verify happens inside the cluster to block anything that's not signed. And finally, you generate a software bill of materials, or SBOM, basically an ingredients list for your software, for total transparency.
Your next quick win is super simple, but incredibly powerful. After this explainer, go scan your main application image with Trivy. Then generate an SBOM for it. I'm telling you, these 2 actions alone will give you more visibility into your production environment than you have ever had before. We've reached our final domain, the last 2 layers, protecting the foundation. This is all about the assume breach mindset. Okay, an attacker got in. Now what? How do you spot them? How do you stop them? And how do you prove your cluster is still configured securely? The biggest threat here is an attacker moving around your network, completely undetected. The solution is runtime threat detection with a tool like Falco. It uses this amazing kernel technology called eBPF to see every single system call, making it pretty much impossible for an attacker to hide. The second threat is configuration drift. The solution? Automated compliance scanning against industry standards like the CIS benchmarks, using a tool called Kubernetes.
And this is why these tools are game changers. The signals are just crystal clear. A Falco alert is unmistakable. Shell spawned in container. Bam. That's the 3 a.m. wake-up call you actually want to get. And a Kubernetes result is just as direct. A clear fail against a known security standard. No ambiguity. You know exactly what you need to fix.
And hey, don't just take my word for it. Look at this. This is the official breakdown of the Certified Kubernetes Security Specialist, the CKS exam. Supply chain security, runtime security, microservice vulnerabilities. The exact topics we just covered make up a massive 60% of the entire test. The industry itself is screaming at you. This is what matters.
Okay, we've covered the 8 layers of a secure Kubernetes fortress. But listen, knowledge without action is useless. So let's turn this into your mission for this week. Here it is, your 4-step mission. 1. Run Kubench to get a security baseline. 2. Implement just 1 default deny network policy. 3. Enable pod security admission in audit mode. And 4. Scan your top 10 container images with Trivy. This isn't weeks of work, people. This is maybe 4 hours of your time, and it will give you a 10-fold improvement in your security posture. Go do it.
This is the path to a hardened cluster. If you want to go deeper on mastering DevOps, acing certifications, and shipping secure software way faster, you know what to do. Thanks for watching.